Hi, so in this video I want to talk about Python's assignment expressions, and you may have already run across them. They were introduced in Python 3.8, and it's basically this operator over here that we have, which is sometimes called the Walrus operator. Okay, so we're going to talk about this, and there is a PEP, and the notebook that accompanies this video, of course, is linked below. It's in the GitHub repo. And one of the links that it provides is the actual PEP for this particular assignment expression, for this Walrus operator. So I encourage you to read this, and we'll come back to it in a bit towards the end of the lecture. So what is an assignment expression? If you haven't come across that before, it might be a little bit confusing. Well, it is an expression. So what is an expression? Well, an expression is something that Python evaluates. Like, so if you do something like a equals, and then 10 plus 20 times 30, let's say, and then let's do, the 3, something like this. And you don't really need this assignment over here, right? This over here is an expression. So you can run it and it evaluates it. Now, of course, you can put in an a equals in front of it, and this is basically an assignment. But this is not an assignment expression. This is an assignment statement. This is a statement. We're saying a equals and then some expression that Python will evaluate first and then assign to this symbol over here. An assignment expression is something that is able to get away from the statement, but also allow you to do an assignment operation inside the expression. So it's just the expression itself. It's not the assignment statement, but the expression itself can contain an assignment to a particular variable, name in your space, in your namespace. So we still retain the regular assignment statement. So this, for example, is not considered technically legal in Python. If you try to do that, you're going to get an invalid syntax. You still use this approach over here. Now, of course, you can make anything into an expression by essentially putting parentheses around it. So technically, you could do something like this. Let's say x, just to show that a doesn't exist. We're going to create, a already exists. Just to use something that doesn't exist, we're going to use x. And if you see, we actually got a result back. This was an expression, but at the same time, what happened is that it did an assignment to this symbol x. And if we look now for x, we have that in our namespace. Now, of course, writing this kind of Python code is very discouraged and really, shouldn't be done. But now this brings up something interesting. So we can still use regular assignments, but now we also have assignments inside expressions. So we could do something like this. Let's say that you have some big complicated formula, and it's not going to be very big and complicated here, but let's say something like this. And this is your Python code, and you need to debug it for some reason. Well, something that might be a quick and dirty way of doing it, and I say quick and dirty because I wouldn't recommend this as actual production code, but you can do something like this saying, well, I want to know what this inside calculation is as well so I can debug it. So this, I might do something like this. I might go ahead and do an assignment to B, let's say, or maybe I'll call it debug. Okay, like so. So now I've got my a, which was equal to 1, and if I want to, I can look at that debug value, which was 6. So this can be quite useful to define long formulas and extract subcalculations into variables, usually for debugging or for fairly easily, extracting the subcalculations for further processing. But in production, I probably wouldn't assign a subcalculation this way using a Walrus operator. I might actually go ahead and write it in separate lines. So I might say, well, debug. In this case, it might not be debug anymore. I'll say 2 times 3, and then I'll say a is equal to b mod 5, like so. Okay. So I would do it this way. But in a pinch, and when you're trying to debug something, you don't want to change maybe the code. You just want to see what this thing inside is. Go ahead and use that. That's probably fine. So there are quite a few more contexts where the assignment expression syntax can actually be really useful. Consider this example where we have a list of strings. I'm going to copy that from the notebook so I don't have to retype everything. So we have this list of strings, and we want to transform that list into basically a list of all the characters, the unique characters of each string, but only for cases where the number of unique characters is greater than 1. So for example, I wouldn't want to capture A, or AAA because there's only one unique character in those strings. But I would want to capture AB, AAB, and so on because there are more than one. And what do I want to capture? I want AB out of this one. I want AB out of this one. I don't want the repeated ones, right? And I want AB out of this one as well. So we can use a list comprehension to do this. We can go ahead and say result equals, and let's go ahead and say we're going to take the set of the characters, and I could join them back into a string. I'm not going to bother. And then I'm going to iterate through every string in L, but I only want this where the length of the set is greater than 1. Okay, so I want more than one unique character. So we can go ahead and write a list comprehension this way. And indeed, we get exactly what we wanted. We have, AB, AB, and AB, those three essentially. But you'll notice that we had to calculate this set twice, over here and over here. Now, it's a very cheap calculation, so in this case, it doesn't really matter, right? It's very cheap unless you're doing it over and over and over again, in which case, well, it's going to start adding up. Or maybe this is a function that you're calling, and that function is fairly expensive. Maybe it has to, make a round trip to a database and get some information from there. And now you've got latency and all kinds of things. And so you may want to avoid having to do this, right? In every loop. So now at this point, what can you do? Well, nothing much. You really have to break this out into a loop. You can then create, a variable. So something like this. You might start with result equals that, and then for element in L, and then we're going to say that the set, let's say, is equal to the set of EL, and then we're going to say if S, the length of S is greater than 1, then we're going to append. So we're going to say result.append, and then we'll append the set itself, like so. And so we'll get the same result in the end. But this isn't very Pythonic code. As we know, we tend to prefer things like list comprehensions over something like this, where we have, an empty result and then we keep appending. But it's not possible to get away from, calling this thing twice using a comprehension. And this is where the Walrus operator comes in, because now we actually can. Let's go ahead and do this. Let's say result equals, and I'm going to call it characters for EL in L. Now, where is this characters variable coming from? Well, it's going to come from when I do the length calculation. Instead of saying set EL, right, like so, greater than 1. So originally what we had was this, right? Set EL. This is what we had. So now what I can do is I can do an assignment at the same time as I'm doing this expression over here, len of set of EL. And I'm going to call this characters. Now here I have to use the Walrus operator. And so this is going to create, essentially, it's going to do this calculation, assign it to characters, and then it's going to continue evaluating the expression, calculating the length. So here I don't have to call set EL again, I can just use chars. And then we'll close off our list comprehension, and then let's print the result out. And if I do it correctly, you see we get the same result. Now again, using the Walrus operator here, this is a fairly cheap, computation. Maybe it's worth it, maybe not. But consider the cases where both the if clause and the elements we want returned are based on some long-running function. So I alluded to that. Let's go ahead and actually just kind of simulate that a little bit. So let's say import time. And we're going to create this transform function, which is really not going to do much, except it's going to take a long time to run. All right. So we're going to let it sleep for 0.2 seconds. Then we're going to say sign equals 1 if x mod 2 is equal to 0. Otherwise, it's going to be -1. And then I'm going to return the sign times x squared, like so. So this is my transformation. It doesn't really do anything, but it does take a certain amount of time. So let's go ahead and create a list. And let's say this is going to be 1 through 10. So I'm going to do it this way. range 1 through 11, like so. You can see this is now the list 1 through 10. And now I'm going to go ahead and do some timings. So time.perf counter, and then we're going to say result is equal to, and I'm going to transform x for x in L if the transform of x, so that same value basically, I have to recalculate it here, is greater than 0. Okay, so I only want to keep the positive, transformed values. And then we'll do again the perf counter to see how long it took. Then we'll print the result, and then finally we will print the elapsed time. So we'll say elapsed, and that's going to be end minus start. We'll do just a single digit after the decimal point, and that of course is going to be in seconds. And once I fix my problem, it's called transform. There we go. So you can see it took 3 seconds to run this, and it only retained the certain values. So we had to do this calculation twice. So now let's go ahead and change this and actually use the Walrus operator as we've seen before. So here I want to give this a name. I need to give it a name, so something like that. Now, of course, it has to be an expression, right? So what I need to do is I need to put this inside the parentheses. And now that I've done that, I can go ahead and use that same, value, that same symbol over here. So if we do that, you'll notice that we'll get the same result, but it took less time to run. Okay, so here's another scenario where the assignment expression can be useful as well. For example, let's say we're building up a list or a dictionary of values, and one value of the list might be based on the previous one. So let me go ahead and do this. Let's go ahead and do this list, and the first value of the list is going to be 10. But what I want to do is I want to use that previous value in the next element of my list. So I know it's hard-coded, right? But you may be running in cases where you don't have a hard-coded value here. Maybe it's running inside a loop. We'll get to those kinds of examples in a bit. But here, I want to reference that 10, whatever it might be, and use it to calculate my next value, which is going to be that previous value plus 10. So I would have to say 10 plus 10, something like this. And then maybe the next one that I want to do is the sum of those previous two. Well, that would be 10 plus 10 plus 10, like so, right? So what I'm going to do is I'm going to use an assignment expression here. And what I'm going to say is start is equal to 10, like so. So now this has become an assignment expression, and I have a symbol start that now has the value 10. So what I can do here is I can use start plus 10. But I want this intermediate calculation as well. So I'm also going to make that an assignment expression, start plus 10. And then my last one, I don't need to assign it to anything, so I'm just going to do the calculation. Just the plain expression. Okay, so now if we look at L, you see we have 10, 20, 30. Now this works with dictionaries as well. So we could do something like this. We could say start, and then we'll say start is equal to 10, like so. Again, the assignment expression. Then we'll do intermediate, and that's going to be, well, we're going to calculate it and also assign it to a value, to a symbol, I should say, called intermediate, start plus 10. And then lastly, we'll do, let's say, the last element, and that's going to be start plus intermediate, like so. And if we print out what D is, you can see we have the same thing. Okay, so now, hopefully you've got a kind of a good understanding of how this assignment expression works. Now it's really just a question of, well, when do I use it? And we saw some pretty trivial examples here. We saw things that we probably would never do in actual production code. This is really just to try and explain how this assignment expression works. So let's look at a slightly more realistic example. And suppose we've got a deck of cards and we want to randomly select a hand, hands of 5 cards from the deck. But we only want to retain the hands that have at least 1 card of each suit. And for each hand, we also want to calculate the frequency of cards in each suit. Okay, so this is the example we're going to do. And if you want to see again this description that I just said, you can look at the notebook that's in the Git repo that's linked below this video, and I have the explanation of what we're trying to do. But let's go ahead and just build it. So the first thing we want to do is to build, let's say, our suits. So I'm going to use this. I'm going to use spades, hearts, diamonds, clubs. I'm just going to use the letters, right? So those are going to be my suits. So this is going to be a list with those single character strings. And then I have the faces of the counts, which is going to be 2, 3, 4, 5, 6, 7, 8, 9. Plus, I also need the 10. So I'll do it this way. And then I also need the list of the Jack, Queen, King, and Ace. And actually, I could just put it over here, but I want to retain the order this way. So I'm doing it like this. Jack, Queen, King, Ace. Like so. Okay, so those are our suits and our faces. And then I want to create a deck. Well, a deck is going to be what? It's going to be one instance of each suit, right? So the deck is very easy to create now. We can use a comprehension for that. And we're going to use tuples for the face and the suit. And this is going to be for S in suits and for F in faces, like so. And this is our deck. We can go ahead and look at the deck. You can see it's got the 2 of spades, the 3 of spades, all the way up to the Jack, Queen, King, 10, Jack, Queen, King, Ace, and then it starts again with hearts and so on. So that's our deck. Now we can select 5 cards randomly from this deck by using the random module's choices function. So let's go ahead and import random. And then I'm also going to set a seed right now. I'll set it to 0. And basically I set a seed so that we have repeatable results. Okay, so you and I should have both the same results when we do our random functions here. So how do I pick a hand? Well, I'm going to say it's random.choices. I'm going to pick from the deck. And I want to pick 5 counts. Okay, and then we can look at the hand, and we have the 6 of clubs, the 2 of clubs, the 10 of hearts, and so on. Now for this hand, we want to count the number of counts for each suit. Well, a very simple way of doing that is to use the default dict from the collections module. So let's go ahead and import that. So from collections, import default dict. And then let's write this function that's going to do the count. So we're going to count the suits basically in the hand, like so. So we'll say result is equal to default dict with an int. So basically this means that the default dict, and it's like that, is going to be an integer default, which means it's going to default to zeros for every key in the default dict that doesn't exist when we request that key. And now all I need to do is just to basically iterate through the hand. So I'll iterate through the face and the suit in hand. And I'm going to say the result for the suit plus equals 1, right? I don't have to check does it exist already, in which case I set this to 1, otherwise I append 1 because I'm using a default dict. And then we're going to finally return, and I want to return a regular dictionary. So I'm just going to return the corresponding dictionary of that default dict. So that's my suit counts. And of course I can call that now on my hand, right, that I just created. And once I fix the problem, default dict with a D. All right, we see that we had 2 clubs, 2 hearts, and 1 diamond. But what we really want is just to know if the hand's at least 1 count in each suit. So I'm going to write this function here, hand has all suits, and then we'll pass it the suit counts, okay? Because in the end, that's what we want to know. We want to know, do we have a hand that has at least 1 count of each suit? And basically, the easy way for me to do that is to take the length of suit counts and make sure that that's equal to 4, okay? The suit counts being what's going to get returned from this. It's going to be this dictionary that's going to have an entry for each of the suits that appeared in the hand. Now, if the suit wasn't in the hand, there won't be a key for it, right? In which case I will not have 4 keys. So that should be quite sufficient to test that. And we can check this. Hand has all suits, and then we'll pass it the suit counts, right? And then we'll pass it the hand. That's what we're doing here. And as you can see, we get correctly that that value is false. Let's try another hand. I'm just going to copy that from the notebook. And then we're going to do the same thing. We're going to say counts equals suit counts. Essentially, that's what I'm doing here. If I can type. Counts equals suit counts. And this is going to be for this particular hand. And then we're going to say hand has all suits counts. And let's call this that. Let's call that, well, let's just go ahead and print hand has all suit counts. And then we'll just print the counts as well. Okay. So we should be able to see that. So you can see that we had one spade, one heart, one diamond, one club. That's precisely how I kind of set up this hand. And so the result here is true. Okay, so now we kind of have everything that we need to generate our list of randomly selected hands, filter out the ones that do not contain at least one count from each suit, and then also calculate the frequency distribution of the suits in each hand, right? We have this over here. This counts over here is doing precisely that. So again, let's build this step by step. So the first thing I'm going to say is hands is equal to, I'm going to use a list comprehension here, and I'm going to do random.choices deck k equals 5, like so. And then we can also reset the seed here if we want to. I'm not going to bother, but if you want to get repeatable results, you know, especially within in a Jupyter notebook where you're kind of, you know, doing things and rerunning cells and so on, you may want to reset your seed occasionally if you want to have really repeatable results that others can follow along with you as well. So here we're going to do this 10 times. So we're going to create 10 hands that are going to be basically these random selections of 5 counts from the deck. So we can take a look at what hands is. We can see that we have 10 hands that were randomly selected from the deck. Now let's add in the filter clause, but without using the Walrus operator. So one thing to note is that for each iteration, we need to be using the same hand in every calculation, the suit counts and the filter clause. So I'm going to do something here that I know is incorrect, but let's go ahead and just do it just so you can see why I'm saying it's incorrect. So let's go ahead and write this hands. And what do I want for the hands? Well, I want the random.choices and deck and then k equals 5, like so. And then we'll do that 10 times and range 10. And that's the underscore. And we're going to say if hand has all suits, I maybe should have found a shorter name. And let's do the suit counts now of what? Well, I need to get a hand. How am I going to do that? Well, I have to use this random.choices, right? So let's go ahead and do random.choices. And what am I going to pass it? I'm going to pass it the deck, and I want a length of 5, okay? Like so. And so there's a problem here, right? Let me go ahead and say print, and then we'll print the suit counts, the hand for hand in hands, right? Technically, I should only have suits in hands where I have one, count of each suit. But if you see what's happening here, I'm repeating this selection, this random choice selection 2 times. One time to see if does this hand have all the suits, and then one other time when I actually want to put the result of that hand inside my hands list. And of course, those are 2 separate calls. Those are going to be 2 separate decks. They're not the same decks. And once I fix my problem here, let's see what the problem is. Name deck is not defined. So let's call it deck with a K. So you can see that I have hands that do not have every every suit in that hand. You can see this one here doesn't contain diamonds. This one here doesn't contain clubs. And so that's why I was saying that this is wrong. We need to be using the same suit the same deck, the same hand, I should say, over here that we use over here. And again, there's no easy way to do this using a list comprehension unless we use the Walrus operator. And then it becomes quite easy to do. And you can do it without using a list comprehension and without using this Walrus operator. You can go ahead and look in the notebook that I have. I have an example of how to do that. I'm not going to cover that here, right? What I want to do is I want to show you now how we can do all this simply by using the Walrus operator. So I'm going to go back in here and I'll grab all this. And then what I'm going to do is I'm going to make an assignment. I'm going to say the hand is equal to this thing over here. And then when that's the case, all I need to do here is the hand. And if I want the frequency distribution, now that's simple because all I need to do is just to say hand. And then I can say suit counts of hand. Now I'm doing that same calculation twice. And then I'll remove this print statement. Okay, so now we can look at hands, and you can see that we have the hands over here, and each hand really has, at least one of each suit. We have that over here. Now I am doing another calculation of suit counts. I'm doing that twice. So what I could do here is just say frequency equals like so. So I'm going to use another Walrus operator here, and then I'm just going to return frequency here. And you can see we get the same result. Now let's look at another useful application of an assignment expression, and that's with while loops. Now consider this example where we're receiving user input and we want to keep prompting the user for an input until the valid input has been received. So one way that we might do it, and I'm just going to copy paste this to save time, but let's just go through the code. So I'm going to have a function called validate flag, and it's basically going to check that the user typed in either a Y or a N, uppercase, lowercase, I don't care. Then I start with a flag saying, well, it's not valid, it's false, right? This is not a valid input yet. And then I'm going to do a loop, which is going to loop until this flag becomes valid. So initially, it's not valid, so it's going to run this loop at least once. I'm going to ask the user for an input. Do you want to abort? Yes or no? Then I'm going to validate the flag. If it's not valid, I'm going to print a message saying, hey, please enter Y or no. Otherwise, the is valid is going to be true. And then when it does the next expression, it's going to basically bail out of the loop. The loop is terminated. And then you will print the result. You decided. If it was false, they didn't enter Y or no, it will just keep doing this loop again and again. So if we run this, do you want to abort? I'm going to say, yes, I want to abort. And it says, no, you need to enter Y or Y, right? It's going to just keep going until I tell it something that it wants to see. So I'm going to type in, let's say, capital N. Do you want to abort? No. And so you decided no, okay? Now, we could rewrite this without keeping that is valid flag around altogether by using an assignment expression. So let's go ahead and rewrite this whole thing using an assignment expression. So I'm going to say while not, and now we're going to say validate flag, and then here the response is going to be equal to the input, and do you want to abort? Do you want to abort? And let's say yes or no, and that's going to be the condition for our while loop, right? So you'll notice that what I'm doing is I'm calling this validate flag on input. So that would be a one-time thing, but I'm going to store the result of input inside response, okay? And then I'm going to say print. Well, if I reach inside this loop, why would that happen? That means that the response was false, right? That this validate flag response was false. So I need to give the same basic error message that I had over here saying, no, you need to please enter a Y or an N. Now, when will this loop exit? This loop will exit if this validate flag returns true. And so at that point, if I type in a yes or a no for the input, that will be inside my response. It will get then passed to validate flag, which is going to say, yes, it's true. So not true is false. We exit the while loop. And so when we exit the while loop, what do we have available? We have this thing available over here, right? I didn't have to call it response. Don't think this response and this response is the same thing. Let's just change the name just so you can see like so. okay? So once I've exited this while loop, it only exits if I typed in a yes or a no, and then our ESP is going to contain what the user typed in. So I might say no, or I might say, some junk, and then I'm going to say yes, okay? And then you can see that we get you decided yes, we got that. So we were able to rewrite, basically this whole thing over here this way. And that's pretty neat. Now, another area where the assignment operation comes in useful is when you're using functions such as any and all. And this is really quite an interesting one, because these functions, any and all, will test whether at least one element or every element of an iterable is true. Just as a reminder, here's how it works. Let's say we have true, false, and false, okay? Like so. And then we get true because any, we have a true in there, so at least one of them is true. If we did all, then of course that's going to be false, because here we want to check that all of them are true, and of course that is false. Now let's look at this example where we have a list of strings, and we want to ensure that every string in the list is at least 2 characters. So I'm getting this data from somewhere, right? So I've got a string AA, BB, then I've got a string with just a single character C, and another string with 2 characters. And I want to ensure that every string in this list is at least 2 characters. Well, that's easy enough to do. I can use the all, and I can say the length of S greater than 1 for S and L, right? So I can use a generator here, and a generator expression, pass it to all, and it's basically going to, this is going to become a Boolean value. Is the length of the string greater than 1 for every one of those? If all of them are true, then I pass the test. And of course, that's going to be false because C is a single character. If I change that to C, you can see, to CC, you can see that it now becomes true. So let's go back to this, and that's false. Well, that's great. Now I know that, well, I have a bad input in here. But I don't know which one caused the bad input, right? What was the first element that caused this all to fail? Because, of course, all, if the first element that comes back as false inside the all, input, the all will stop processing at that point and return false, right? It doesn't need to keep, processing the remaining things. It basically short circuits the evaluation. But I'd like to know, well, which one did it fail on? What was the first one it failed on? And, normally you might go about it doing something like this. You'd have to kind of break things out and do it yourself. Is okay equals true, and then example equals none. Then we're going to iterate for every string in the list L, and then we're going to say if the length of S is less than or equal to 1, then is okay is going to be false. That means that our overall result is going to be false. We're going to set our example now because I need to know what was it that caused it. And then at that point, we also do short circuiting. We break out of here because, well, there's no need to continue. We found one false thing, right? One false value. That's good enough. And so here we can say if not is okay, or if not is okay, then we're going to print something like this. Invalid string found, and that's going to be our example that we had over here, okay? Like so. So you can see invalid string found. So that's one way of doing it. But now we can leverage the Walrus operator. If we go back to this over here, we can say is okay. Let's say we want to keep this flag is okay. And we're going to look at this. But what I'm going to do here is I'm going to actually assign this element S to some other thing. So here, let me call it example, let's say. And I'm just reusing the same name that we had before. Don't have to. It could just be a new name, a new variable name. But you'll notice what's happening now is that all is going to do this iteration. At every iteration, it's going to take this S that's varying, and it's actually going to store it inside example over here. So when we do that, we can now do the same thing that we had before. I'm going to take the same output, and you can see that it found an invalid string C. So we were able to leverage the assignment expression here in order to keep track of where all stopped processing. Now here's another also kind of fun way to use the Walrus operator, and that's for accumulations. Suppose that given a list of numbers, we want to produce a cumulative sum of the squares of each number. So let's take a look at how we might do it more traditionally. So I might have data that's going to be, let's say 1, 2, 3, 4, 5, and 6. Okay. Then I'm going to keep an array or a list for the sums, and I'm going to keep this cumulative sum. I'm going to call it sum underscore because sum is, of course, a built-in function. And then we're going to iterate for num in data. And I'm going to say my cumulative sum is equal to my cumulative sum plus the num squared, right? So I'm going to keep a cumulative sum of the squares. And then I'm also going to append this now to this value to the cumulative sums. So basically I'm keeping track of the cumulative sums at every iteration, and then I'm storing the interim cumulative sums inside a list. And we can go ahead and just print out what sums is, and you can see that we have 1, 5, 14, etc. But now we can use an assignment expression instead to do this. Let me show you what I mean. Let's say that sum is equal to 0. So I'm going to use this cumulative sum over here. And then I'm going to create a list comprehension. And how would I calculate the final cumulative sum? Well, I would have to kind of add everything up, right? So I need to know what the previous cumulative sum was. Well, in this case, what I'm going to do is I'm going to actually say this is the previous sum, right? Let's say this is the previous sum plus the number squared, like so. And this is going to be for num in data. But what is this this sum underscore? Well, right now it's just 0. But at the next iteration, what do I want it to be? Well, I want it to be what the previous one was, right? So all I'm going to do here is going to say sum underscore is equal to. So I'm going to replace. So I am going to have to define this outside of the comprehension because I need a start value. But once I've got that, at every iteration, it's going to calculate the sum, whatever this value is currently, plus the new value. It's going to add those two together, and it's going to store it back into sum. That's what this assignment expression is doing. And so when we do that, and if we run this, you'll notice that, well, we have exactly the same result. So this is a lot more concise writing this down. Now we can actually even use this to calculate consecutive factorials without using recursion. We could use the same technique this way. We can say, let's say our initial product is 1, and then we're going to say the product is equal to the product times the number, right? That's how we do factorials. We take the 1 times 2 times 3 times 4 times 5 and so on, and we take, so whatever the previous thing was in the factorial, so factorial of n is really n times the factorial of n minus 1. And that's exactly what we're doing here, but we're not using recursion for this. So for num in, let's say, range, and let's go 1 through 6. So we'll calculate the factorials of 1, 2, 3, 4, and 5. And you can see that's how that works. And again, this is simply because we're able to keep track of what the previous product was at every iteration by using this assignment expression inside a comprehension. Now, there are some limitations to where you can use this new operator. You cannot use it in iterable unpacking. What I mean by iterable unpacking, let's say I've got t equals 1, 2, 3. You can unpack this way, right? You can say a, b, c equals t, and then you'll see that we have print a, and then b, and then c, right? We unpacked a, b, and c into, well, we unpacked t, I should say, into a, b, and c. So you cannot use that in assignment expressions. So you will not be able to, even inside an expression, be able to do something like this. That's just not going to work. That's one limitation. You can also not use it in augmented assignments like plus equals, times equals, right? You know that if we have a equals 1, then we can say a plus equals 2, and then that a is now 3. You do not have an equivalent for this with an assignment expression. The assignment expression is only the equal sign. That's it. You also cannot use it to create an attribute on a class and return that value at the same time. So let's say we have this class person, and it's not going to do anything. We're just going to pass, basically. And then I'm going to create an instance of person. And then I can create an attribute on this, right? I can say name equals Fred, for example. and then I can look at the name attribute on that person object. That works just fine. What you cannot do is something like this and say p.name and then the assignment expression Fred, right? Even if you do something like this and put it inside an expression, that is not going to work, okay? You cannot use an assignment expression with an attribute. Now, there are a few more cases where you'll not be able to use the operator, but most of the times these are cases where it wouldn't make sense anyway, and hence why these cases are not supported. And I urge you really to take a look at the PEP, and in particular, if we go back to this one, take a look at Appendix A. This is something that Tim Peters wrote, and he was skeptical, right, at first of where am I going to use this thing? Because, for example, you know, he does not like writing things kind of together, right, that don't make sense. So, I mean, go through the explanation. You'll see it makes total sense what he's saying. And yet he finds ways where, you know, so he's going to really tell you when it doesn't make sense to use the Walrus operator, where you really shouldn't use it, even though you can. You probably shouldn't. And in cases where it does make sense to use that. So this is a really good section of this particular PEP. I encourage you to read it. And that's the Walrus operator. Thanks for watching.